Today's focus is going to be on nuclear reactions. With nuclear reactions, you will be seeing the presence of 5 different types of radiation particles. On this slide, you can see 2 of them. Those 2 are the alpha particle and the beta particle. You will need to have these memorized. So the alpha particle is just the helium nucleus. So what does that mean it is? The alpha particle means, if it's a helium nucleus, means it has 2 protons and 2 neutrons. Okay, so it's without the electrons basically. A beta radiation is a high energy electron. I could have said an electron, but they also say it's beta. Okay, so you can use them kind of interchangeably, but definitely get used to the word beta. When you are talking about their composition, an alpha particle, because it is a helium nucleus, looks exactly like a helium particle to you. You can also write the symbol as an alpha. These are all the Greek letters that we are going to be using. So it kind of looks like an A or like one of those fishes type of thing. What this means for nuclear equations, though, is the top number represents the mass number, and the bottom number represents its charge. So when you are dealing with nuclear reactions, you will notice that it's a little bit different than if you actually see a chemical equation. And the reason why is because you will have, they will ensure that you know the mass and the charge of every single element. Like the nucleus's charge, I guess you want to kind of think of it as. So the bottom number represents the charge. Okay, and then a beta has because it is just an electron, you got to think through it. What is the mass of an electron? The mass of an electron is 0. And what is the charge of an electron? The charge of an electron is a -1. And this is the Greek symbol for beta. Okay, and they have a net. You can either see it like that or with the negative sign. That just means that it has a negative charge. It's kind of like when you write a neutron with a 0 or proton with a positive. It's kind of a little bit redundant. Okay, as far as alpha radiation's charges, because you're going to look at the bottom number, that would be a +2, and betas would be a -1. I want to show you an example of a nuclear reaction with an alpha particle in it. Okay, so this is how all nuclear equations go, is you start with something, and it could have other things also on what we call as the reactant side, and then it's going to produce 1 or 2 or 3 or 4, whatever amount of things. Okay, but how I want you to know that it's alpha is you'll see, oh, here's your alpha particle. So it's going to be an alpha nuclear reaction. Okay, beta, you'll just look for that beta particle. Oh, and there it is. Okay, we will get into how to actually come up with these equations in a little bit. These are the other 3 particles that you're going to absolutely have to know. The one is a positron. So, I guess I'll go over to that in a little bit. The positron is a positive electron, and so its symbol is the exact same thing as you would think, okay, as the previous page was. The top number represents the mass. The bottom number represents the charge. So you could either write 1 or +1. I've seen both. And then the symbol, because it's a positive electron, you write an E. The charge would be a +1, and I'm going to look for it in my example, and here it is. So it would have positron radiation. Okay. Gamma is just high energy radiation. Its mass is 0 and its charge is 0. Okay, so you can either write that one loopty thing, or it's preferable if you actually write the mass and the charge next to it. So the charge would obviously be 0, and here is it found in here. I couldn't find the right symbol, so I apologize for looking like a V. And then we've got the neutron. The neutron is exactly what it is, what it sounds like. It is a neutron. So what is the mass of a neutron? Is 1. Its charge is 0. Its symbol would be N, and that's why it's charged down here 0, and here is your neutron right here. All right, you are going to have to be able to memorize these. And so I have a few ways to memorize some of them. If you look at the alpha particle, if you think of an alpha male is always a he. If you go to like the wolf packs and things like that, alphas are males. So it's a he, right? And so what is its mass? It's 4/2, okay, with its charge. Okay, so that's how I remember alpha is he. It's for helium. It's also a he. It's always the male. All right, then we've got beta. Beta is the only one with an E. So what is an E? Oh, an E is an electron, which means its mass is 0 and its charge is -1. Then we've got gamma. gamma, I see a double A, I see a double M, so I see a double 0. So that's gamma. And then you've got positron. If you just look at the words that it's kind of made up of, you've got a positive electron. So we've got a mass of 0 because it's an electron. It's a positive electron. We've got a positive 1. Its symbol would be E, and this would be your positron. And then you've got a neutron, and a neutron is just a neutron. There's no like gimmicks to it. So it's got a mass of 1, it's got a charge of 0, and its symbol is N. So those are the different ways that I actually remember these, because otherwise it's a little difficult to remember like what the heck is an alpha particle, right? What's a beta particle? Okay, so let's just look at their bombardment power as far as particles go. So looking at the top or the bottom, whichever one you want to look at, which one has the most penetrating power? Penetrating power means which one can go through the furthest. And so if you look at that, you would see, oh, we've got gamma. Okay, because it could go through everything. And it was stopped by concrete, or in this guy, it is stopped by some lead. Okay, and then what particle would a positron be most like? Well, positron is exactly like a positive electron. So therefore, it's going to fly the very similar way to an electron. What's the electron? Oh, that's the beta particle. So it would be most like a beta particle. And what stops that beta particle? Well, in the first one, it's stopped by wood. And then in the second one, it's stopped by your hand or plastic. Okay, alpha particles are stopped by a piece of paper. And why is because they have such a heavy mass of 4 that you can stop it with very thin things, right? Because it's so big it can't get through those open spaces. All right, flight with magnets. So let's try to understand with this. So we have a magnetic field on here, and we've got a positive and a negative. And because these particles have charges, they're going to be attracted to things that are their opposite, and they're going to be repelled by things that are their similarities. So we're going to focus though on what they're attracted to. So a beta particle, which is that high energy electron, has a negative charge, so therefore it would be attracted to a positive end. Gamma, because it has no charge, it is just 0 over 0, so 0 mass, 0 charge, it will not be affected by either a positive or a negative charge. And an alpha particle, which is the helium nucleus, is 4 over 2 He, so it has that positive 2 charge, so it will be attracted to a negative. Now think about it, where do you think a positron would be attracted to? Okay, so a positron is, remember, a 0, a positive 1, and an E. So which one do you think it would be attracted to? Well, it would be attracted to the negative because it has a positive. All right, you're going to have to also label what type of nuclear reaction is going on. Okay, and so what it is it totally depends on where the nuclear particle is. Okay, and the nuclear particle are those gammas, betas, positrons, and alphas. Okay, and we'll talk about, I will talk about the neutron in a little bit. Okay, so we've got gamma, beta, positron, alphas. Now, if you see these particles, and it doesn't matter which one, because there will be blanks on yours, and you'll see that on shortly. It doesn't matter where the blanks are, it all depends on where these 4 particles are found. If these particles, or one of them, is found on the left side of the arrow, you are going to use the words absorb, bombard, or capture. So if you see a gamma particle on the left-hand side of this arrow in a reaction, you would say a gamma absorption or a gamma capture. If you saw it on the right-hand side, you use the words decay or emit. So a gamma decay or a gamma emission. Now they do use different terms for the different particles, but you do not need to know those. Okay, so they typically say like a neutron bombardment or an electron capture or beta decay. Okay, they usually use different words with the different nuclear particles, but do not worry about that. What I want you to understand is that you can use these guys interchangeably and these guys interchangeably. Okay, for this particular class. So if you see a gamma particle on the left-hand side of the arrow, you can say gamma absorption, bombardment, or capture. Don't care which one you choose. If you see on the right side, you choose decay or emit. Now, how can you remember those? Very, very easy. A, B, C's are on the left-hand side. D's and E's are on the right-hand side. Okay? Now, let's look at the example. So I find my particle. Oh, look, my beta particle. So my beta is on the right-hand side. So I would say beta decay or beta emission, whichever one you want to do. You could also say electron. Okay, it's just a high energy electron. Now, you should also note that I have not talked about fission or fusion. For this class, how I teach it, which is not exactly correct, and I understand that, but it just makes it a little bit easier for this class. If you ever see a neutron is going to trump any other particle. Okay, so if we see a neutron, it's going to trump everything. Okay, when you see a neutron, what you are going to decide between is fission or fusion. Okay. Fission is division, okay? Fission is where a particle divides up. So what you're going to have is you're going to have a big particle going to two smaller particles. Fusion is where you fuse things together. So you're going to have two small particles, and they are going to merge to make one bigger particle. Now, when you are trying to decide between fission and fusion, you will not use the words absorb, bombard, capture, decay, or emit. It literally is just fission or fusion. Even if you see an alpha particle, you're always going to go with fission or fusion. Okay, so even if you see the other particles, just go with, for this class, we're going to make it simple. It's fission or fusion. Okay, now what you want to do though is you're going to want to cover up the neutrons. So let's say I had a neutron and I had a big guy, and then I saw it go into two smaller guys, and let's say 3 other neutrons. Okay. What you're going to do, if you're trying, first you're like, oh, I know it's fission or fusion. What you want to do is you want to cover up whatever neutrons you've got. So I'm going to cover these up, okay, because we're going to look at big picture. And what I notice is that it's going to go from 1 to 2. So you always cover up your neutrons, and then you figure out, is it going to be fission, meaning 1 go to 2 things, or fusion, where you go 2 to 1 big thing, okay? And in this case, this would be a fission reaction after you got rid of all those neutrons. All right, so let's try some practice problems. Very simple. It is basic algebraic math, okay? So because of the law of conservation of mass, the tops have to equal each other on both sides of the arrows, and the bottoms have to equal each other on both sides of the arrows. And so your job is to come up with what would make this mathematically equal each other. So on the top, we have 242, okay, equals, so instead of seeing an arrow, I would see an equal sign, equals 4 plus, and this is my variable, so I'm going to write it as x right now. Now you can do this mentally. You do not need to write them out. Sometimes it is more beneficial to write it out, but sometimes students get actually confused by doing that. So especially when there's not a lot of space to do it, you can do it. If you can do it mentally, go for it. If you can't, go for it, whichever way works for you. So if I solve this, I get x equals 238. So I'm going to write 238 on the top. Okay, let's do the bottom now. I'm changing up colors just so you can figure it out, see it easier, I guess. So we've got 94 equals 2 plus blank. So here's how I'm getting it. 94 equals 2 plus blank, okay? And so that would be my x, so x equals 92. Now the bottom number is always going to be your atomic number because it's the number of protons, it's the charge of your nucleus. So we are going to go look on the periodic table for what that bottom number is, and that would be U. So we've got uranium. You do need to write the element, okay? Let's try the next one. It's a little bit easier because the variable's on the left and we only have everything itself on the right. So I'm going to say x equals 32 plus 0. So I know 32 plus 0 is 32. So x equals 32. So I'm going to write 32 on the top. Okay, and on the bottom, okay, I've got 16 plus -1. So it's really 16 minus 1, so we get 15. Look on your periodic table for what number is 15, and that would be P. Okay, I'm going to erase this work right here, so it'll be easier to do something in a little bit. Okay, this next one's a little bit trickier. Okay, so I got the 252, that's easy. 252 plus x, easy, right? So 252 plus, and then x equals, now here is this guy, okay? 3 neutrons, what it's saying, because it's saying I've got 3 of these guys. So instead of writing like neutron plus neutron plus neutron, what we did is we just combined them and we got 3 neutrons. Okay, so what you could do is you could add them all up, like 1 plus 1 plus 1, or what I do is I just multiply this coefficient by by the number. So it would be equals 3 plus 259. Okay, so we get 262, equals 252 plus x, so x equals 10. All right, now let's try the bottom number. So we've got 98 plus x, so 98 plus x equals 3 times 0, so 0 plus 103. So in this case, x equals 5. So I'm going to write down 5, and this would be boron. Okay. Let's try the bottom one, or the next one. So we've got 55 plus something equals 55. So that's an easy one. I don't need to do that. I can do that mentally, so that's 0. If you couldn't, then that's fine. Do the math. So then it's 26 plus a number equals 25. So I need to go from 26 to 25. So I'm going to do a minus 1. Okay, now I've got something with a 0 in it. So this, I can't go look at the periodic table because the periodic table doesn't have anything with a 0, because to me, minimum on the periodic table, you need 1 proton. So what you're going to have to do is go back to your drawing board of those particles, and you're going to have to match which particle is this. And this is a beta, so you're going to put an E. Okay, that's just pure memorization. Okay, and then let's do the bottom one. 15 equals what number plus 0, right? So what number equals 15? 15. And then on the bottom, 8 equals what number plus 1? So 8 equals plus 1. So what is that going to be? That would be 7, which is nitrogen. Okay, now the last thing is that you're going to have to do is you're going to have to be able to identify what type of reaction it is. Okay, and so once again, that's based off of solely what type of nuclear particle you have. First, you're going to want to look for your neutron. If you don't see it, then look for your other particles. So this guy right here is an alpha. And because that alpha particle is on the right-hand side, I can choose decay or emission. So I'm going to choose decay. Then on the next one, we've got beta. This is beta. And what side is it on? It's on the right, so I'm going to say emission for this one. You could have chosen decay also. Okay, remember your DEs are on the right. So now I'm looking for it. Oh, I've got that neutron. So now it's going bing, 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 fission or fusion. So I'm going to cover up that neutron, and I go from 1, 2 to one thing. I go from 2 to one thing, which would be fusion. You're fusing them together. The next one, I see this beta particle, and so the beta, but the beta's on the left-hand side, so I can choose absorption, bombardment, or capture. I'm going to say beta capture. You could also say electron capture, just to let you know. You could say beta or electron. Be comfortable with both, okay? And then on the right-hand side, I look and I see, oh my gosh, I've got a positron. So it's a positron. And what side is on? The right-hand side of this arrow. So therefore, it is going to be decay or emission. So I'm going to say positron emission. Doesn't matter which for this class. All right, hopefully you have a basic understanding of nuclear reactions, the 5 different particles that you're going to need to know of alpha, beta, gamma, positron, and neutron, and can be able to identify what types of reactions they are by absorption, bombardment, capture, if they're on the left-hand side, or on the right-hand side, decay or emit, or if they're neutrons, fission or fusion. Have a great one.